Hey, 7th graders, to finish out our week this week, we're going to close out with the Monohybrid Crosses worksheet. So Monday, you should have watched the lecture about Punnett Squares and Monohybrid Crosses. Tuesday, you had a little bit of practice on Punnett Squares. Wednesday was your STEAM Wednesday. And then yesterday, you guys did the Monohybrid Basic worksheet, which kind of had a lot of review from phenotypes and genotypes, as well as Punnett Squares, our vocab, and then a little bit of Monohybrid Crosses. So today you guys are focusing strictly on using Punnett Squares to solve Monohybrid Crosses. So your learning target is, I can predict the genotypic and phenotypic ratios of a cross between two parents considering one trait. So Monohybrid Crosses are different than other crosses because we're just looking at, say, how eye color are passed down. If we were to look at how two traits pass down together, we might be looking at dihybrid crosses. So we might look at, all right, what combination of eye color and hair color do we see in individuals? But again, we're keeping it pretty simple because you guys are just in 7th grade. This would be something more for sophomore year of high school. So again, we're focusing on just one trait, okay? You have 10 problems that you're gonna do today, and I'm gonna do 2 examples for you. So each of these problems has a similar layout where you are answering basically these first, 1, 2, 3, 4, 5 questions the same on every one, okay? And then your last question will be different for each question, so you guys will just really need to pay attention to what it's asking for you guys. Okay, and then notice again your Punnett Square over here. All right, so your first one is a homozygous tall plant is crossed with a heterozygous tall plant. So what is the trait being studied? So we see we have tall and again tall plants. So obviously we're studying plant height. So you guys could type in there plant height. Okay? What is the dominant allele and phenotype? So this is similar to what you guys did yesterday. You're just basically making an allele key. So the dominant allele, it looks like we're using the capital T in this instance, and that means tall. Okay? I don't really tell you guys what the recessive is, but I think you guys can assume that the lowercase t equals short. So again, I want you guys to write the dominant allele and phenotype and the recessive allele and phenotype like this. You're, again, making just a little key that tells me what does the big T mean, what does the little t mean. Okay, what is the genotype of the first parent? So it really doesn't matter what order you guys get them in. Mainly just list them in the order that the question lists them in. So a homozygous tall plant, I already gave you the genotype right there, so there's not really a ton for you to think about. So a homozygous tall plant would be big T, okay? Versus is crossed with a heterozygous plant. Again, heterozygous means a mix where you have one dominant and one recessive allele. So the genotype for that one would be big T, little t. And again, I give that to you in the problem. Okay. All right. What is the probability the offspring will have a heterozygous genotype? So this is where you need to use your Punnett Square. You can go to your draw tool and click on whatever color you guys choose. Keep it festive. So it doesn't matter which parent goes on the top or the side. So we're going to go ahead and just plug in, all right, that's my big T. I'm going to go ahead and rewrite that because that's a little messy. I want to make sure I can really tell the difference between my uppercase and lowercase. So there's big T, little t is one parent, and big T is another parent. Okay, let's do that one again. All right, and then go ahead and do your cross in here. So we got big T, big T, big T, big T, big T, little t, and big T, little t. Okay. And then look at the question. What is the probability? So remember with probability, we're either looking at percentage or fraction. So out of 4, or you guys might see 0, 25, 50, 75, or 100%. So those are our increments of 4. So what is the probability the offspring will have a heterozygous genotype? Okay, if you need to, look back in your notes and review some of this vocab because I'm not always just going to give you guys the answer. Okay, so heterozygous, remember, means a mix or a combination of both dominant and recessive. So we're looking for a genotype that has a dominant and a recessive allele. So big T, little t. This one does, and this one does. Okay, so 2 out of 4. So again, you guys could either answer 2 out of 4. You can type it or you can draw it. Or 2 out of 4 is 50%. It's 1/2. Okay, so 2 out of 4 or 50%. Okay, so either one of those are acceptable answers. You don't need to include both, but you can if you want. Okay, moving on, I'm going to do question 4 for you guys. So down to slide 5, here's question 4. The reason I am doing question 4 is because it talks about these genotypic and phenotypic ratios, and you will see, I think, at least one other question like that on this assignment, okay? So a dog with black fur, big B, is crossed with a dog who is heterozygous for black fur, big B, little b. Little note here, the recessive trait is brown fur, okay? All right, so moving to my first question, what trait is being studied? We're obviously looking at black or brown fur, so we're going to say fur color. What is the dominant allele and phenotype? So remember, you guys are making a little key. So your dominant allele is your capital letter. In this case, we're using B. Okay, so capital B is black, and lowercase b is brown. Okay, what is the genotype of the first parent? So first one listed is the dog with black fur. He has the genotype big B, or she. What is the genotype of the second parent? A dog is crossed who is heterozygous, so she or he is big B, little b. And then what is the genotypic ratio and phenotypic ratio of the offspring? So let's go ahead and do our Punnett Square. All right, so one parent is big B. Again, really make sure that you guys, if you have to choose your own letters, make sure you guys choose letters where you can easily tell the difference between upper and lowercase. So B's are a great one to use, okay? All right, so go ahead and do your cross. Big B, big B, little b, big B, and big B, little b. Okay, so these ones ask for the genotypic and phenotypic ratio. So back to my cursor, I'm going to click. Remember, when we ask for the genotypic ratio, I want you guys to list all of the different genotypes you might see in the offspring and tell me how many of each there are. Okay, so how many out of 4 would you see? You guys will separate those two pieces of information by a colon, okay? So let's take a look. All right, right here we have 2 big B's. So we're gonna go 2 big B, and then use a colon. And now we're gonna look at our other one. We have 2 big B, little b, so 2 that are heterozygous. So we're gonna list those, 2 big B, little b, okay? Phenotypic ratio is the same, except instead of using your guys' genotypes, you're gonna look at the phenotype. So let's talk about each of these individuals, okay? This first individual has a big B, therefore it has black fur, okay? Also has a big B, black fur, big B, black fur, big B, black fur. So when we're doing the phenotypic ratio, it's gonna look a little bit different. We're gonna say there's only really 2 phenotypes, brown or black, okay? So how many are black? In this case, 4 black. Okay, to how many brown? So you guys would write 0 brown, okay? So 4 black to 0 brown. We will not see any brown individuals there. 100% of them will be black, okay? So those are the 2 examples I'm gonna give to you guys, but I do want to kind of grace over a couple of these really quick. You guys can see some ask for mom and dad. That's because we're specifically talking about a woman and a man, okay? And there's also gonna be some like number 8, where I don't give you guys a letter. You are free to choose your own letter, but again, when you're choosing a letter, pick something where you can really tell the difference between the upper and lowercase. For instance, let's see here, what's a really bad one to use? O's, okay? O's, sometimes you just write your O's and you can't really tell which one's uppercase and lowercase. Okay, especially if you have 2 O's right next to each other and you can't really see what the other side looks like. So make sure you guys use something like B's, A's are good, C's aren't very great because upper and lowercase C's look the same. Okay, D's work great, E's, so on and so forth, but just think about having a letter that's different as uppercase and lowercase. Okay, finally, you guys will move on. Okay, again, this one you guys need to pick your own, review your vocab. Okay, so some of these I stopped giving you guys, like her husband is heterozygous. I did not give you guys a genotype for that. So you guys have to think, what does heterozygous mean and what does that genotype look like? Okay, some of these I ask for like, all right, how many of the offspring will have a homozygous recessive? Again, review your notes, review your vocab so you guys know what those look like. All right, finally, do your wrap up. Do you have any questions? Yes or no? Obviously, if you have a question that's preventing you from finishing this assignment, you guys want to get to me right away on Teams. Okay, if not, type your question right here. And then 4, 3, 2, 1, how do you think you did on this assignment? And nice work. Go ahead, double check you finished everything and answered all the questions, and you may turn this in. I hope you all are having a wonderful Friday.